So hello, yeah, I'm Howard. This is a proof of concept for automatic conversion of R models into Excel. It's not a final product, but it is a way you can see that this might be possible. Funder acknowledgement, this is partly funded by the company Clifton Insight, but also the Reaver project, which is funded by the MRC. All code is available at this GitHub link, public, so you can check it out now if you want. And there's also descriptions there of how it works and a bit of documentation. The first question you might wonder is, why would you want to convert from R to Excel if you already have this hyper-efficient, transparent, flexible modeling in R? Why would you want to export in Excel as well? Well, the problem is that not all HTA agencies are as forward-thinking as NICE and NCPE, Zin. Some do not accept R models. In those cases, you need an Excel model to be able to submit. And companies will want to be able to leverage the advantages of R, but also have this ability to export an Excel version. You could just double program, so write the model in R and Excel, but that means you have two chances of implementing errors, and it makes updating the models very, very difficult and error prone. So instead, what we're suggesting here is that you can write the model in R in such a way that it can write a version of Excel when you ask it to. Requirements are, we want to be generalizable to any, in this case I'm just talking about Markov models for this proof of concept. We wanted to generate a human readable Excel file, and I'll show you what the potential for a non-human readable Excel file is. And we want to avoid double programming, so we don't want to write a template in Excel, a template in R, and just changing the input parameters, because that's not quite the same as what we're trying to do. So you may have seen presentations on Reaver, the tool which automatically converts Excel models into R, and it can gain speed advantages of over 100 times over the Excel sheet. It theoretically works on any Excel model, whether it's a DES, a Markov, partition survival, whatever you want. So you can ask, why don't you just reverse this, just do Reaver in reverse? So to understand why you wouldn't want to do that, you need to think just a little bit how Reaver works. And essentially it's using this abstract syntax tree to represent the Excel code in a language agnostic format, where these are statements and then the arguments to each of the statements. So you could apply this to R code and then export a Python or C++ equivalent of the R code. So that's all possible. But you need to look at what the output of Reaver looks like. So this is the code that comes out of Reaver just on a 4-stage, 4-intervention Excel sheet. It's 2,600 lines of essentially unreadable R code, because Reaver, the abstract syntax tree, doesn't actually know what the code is doing. It just exports it in the simplest fashion. So if we did this in reverse, what we would end up with is many, many cell calculations that are just equivalent to each of the lines of R code. It also would unroll all the for loops, lapply statements, vectorizations into multiple Excel cells. So you'd end up with something that is very slow and very unreadable. So that's why we're not doing this general reverse Reaver method. So instead, we use R to write Excel formulae. And we do this using what we've discovered is very powerful OpenXLSX R package. We'd used this for years to input data into our R models, similar to as Alina showed, the kind of standardized way to do that. But it can also write formulae, and it can also export formatting and drop-down menus, and it's really very powerful and surprisingly powerful. So there's an example usage here where you open a workbook, you can add worksheets, you can export a data frame. The data frame can include formulae. You can specify where you want to write the data frame in terms of the sheet and cell location, and then you just save the workbook. So this package exists and it works really well. Also, we try to keep track of everything within the Markov model using R6 object-oriented programming, so that each model is an object with member functions and member data. So this maps the relationships between the input parameters, the transition matrices, the costs, the utilities, qualies, and this mapping of the data relationships makes it much easier to manage the R to Excel conversion. So our approach has two key R6 objects. One is an input parameters object, the other is a Markov model object. And within those, there are two key functions. One is specify Excel within the input parameters. So that looks at all the member data and functions of the input parameters object and exports a dfspec data frame, which represents everything within the Excel sheet, or with everything within the input parameters set. And the same with the Markov model, there's an export to Excel function, which again looks at all the relationships and data and exports an Excel version of the model. So I'll start by showing how this member function specify Excel works. So the data structure and complete specification of the relationships is really, really key. So this is a data frame df spec within the input parameters class. It tells you what the distribution is, the hyperparameters, because these are probabilities or transition probabilities. You need a from and a to state. You need to say which treatments it's associated with. And then this bit in yellow, this Excel formulae, that's the automatically generated bit. So it's done in quite a naive way. We just use lots and lots of paste statements and lots of thinking about what these functions look like. So here we've got the code that generates the output here, this norm inverse rand I6 J6. And that's done using paste statements, remembering where the data is stored, so which cell location, and that's how we can export this automatic formulae. So the input parameters are relatively simple. It's then the Markov model export to Excel function, which is the second one, which we'll talk about. This generates the state occupancy probabilities using everything that's in df spec. It associates each parameter with its source state, the from and destination to, ignores parameters that don't have a from or to because it recognizes, oh, those are probably costs or utilities, so don't use those. And here are the first, sorry, it's actually in the first row of the, it's the first two rows of the Markov trace illustrated here, and this is generated using the export to Excel function. So I've pasted in the code here. Basically, you can look at the comments to see what it's doing. So we're going to generate the Markov trace using the transition probabilities from Markov inputs. We look which parameters give probabilities from this particular state and are relevant to this particular treatment or to all treatments. That's what these if the conditional logic statements are doing. We need to work out the sum of the probabilities of exiting the state. So to do that, we look at all the states that are from and add them all together using paste statements. We can then generate numeric rows for the previous cohort probabilities. You can see the probability that's been in the previous state. We append them together, and so we can add everything up and generate the Markov trace. A similar approach is taken to costs and qualies. The output model is probabilistic, but it's only for one sample. So you see that there's a norm inverse or a beta inverse, gamma, all those things, so you get one run of the PSA. We then append a VBA macro, which is pre-built because R can't export VBA code just yet. And then once you use this pre-built VBA macro, it can run full PSA. So as long as the total costs and quality cells are written in a specific format, so exported into a certain cell in a certain sheet, the VBA macro will recognize it, and then we'll run the PSA. So let's test it. And don't laugh at the simplicity of this example. This is a two-state, two-intervention Markov model. The approach is fully general. We are testing it on others, but for now, we're just showing you this case. And in this case, it's very simple. There's a standard care with website. It helps people quit smoking. It's just a bit more expensive. This is df spec for utilities. So you see that we need to just be very careful to specify everything about the model. So this is what the utility is in each of these different states. So we sell which V state is it associated with. We leave V treatment blank for both of these because they apply to both treatments, but you could have treatment-specific utilities. We've got df spec for costs. So the df spec includes the cost, utilities, transition probabilities, everything together. Sorry. But in this case, I'm just showing you them separate. Costs, we allow them to be one-off or ongoing. So you could have a treatment cost and then the cost of ongoing care. And then the df spec for the transition probabilities. Here, they're all beta distributions. You could use log normal, whatever you want. And we found that OpenXLSX has an equivalent for every distribution you want. The only issue is that it uses deprecated versions of the distributions. Not sure why, but they work interchangeably. This is the output of our two-state Markov model written in R. So we just run one single function that exports the contents to this Excel sheet. It tells you there's a sheet with the input parameters. And note here the formula bar. So the bit at the very top, that's showing you the complicated bit that isn't just exporting data. So here, the Markov trace, every single one of these rows and columns has been written by R, so it can work. And then the results, it gives total costs, qualities, ICERs, incremental net benefits, etc. And we can compare them. We did this using 1,000 samples. There's only numerical variation in terms of difference between them because of different random sampling. So using this R model, we've exported an automatically exported an Excel version, compared them, and they match. So there's lots of next steps for this. This supplied proof of concept works only on time homogeneous Markov models, so changing it to be time inhomogeneous is the next step. We want to implement the formatting of Excel so we can make the exported Excel look a bit nicer. OpenXLSX allows you to change the colors and the font and the bold and italic, etc. We also want to allow if and index statements to allow switching between scenarios. So your R model could have some scenarios that are all exported to Excel. And we want to test this on multiple toy and real world models. But this does work for any time homogeneous Markov model with any number of states, any allowed transitions, and any specification of utilities costs. So it is already quite a general solution. Thank you for your attention.
Okay, just checking if there's any questions from the room. I have a comment, not a question. Don't look too scared. So the comment is, I think it's possible to build upon this, because I think from Python, you may be able to change the VBA. And you can call from Python from R, as everyone knows. So yeah, so potentially there's a solution for that already. So that's very good. Are there any questions in the room or online? Yeah, Xavier?
Oh, yeah.
Thanks. No, it was very interesting. And this is always, I always thought, is this possible? I'm wondering how painful it is to write the code, to have everything, because at the end of the day, you're sort of translating R to Excel, right, manually. So potentially you would need to translate a lot of functions from Excel, right? Or do you think it can be sort of reduced to a set of functions and that's it?
So the Excel functions are not the issue. So we have tested it, Queen and Edwin have taken this forward and they've looked at the 52 Excel functions that they found are commonly used in Excel models, and they're all exportable quite easily. So that's not the issue. I think it's more the logic of the model. It's like the structural, that's where the pain comes into. And the Markov trace was probably the most painful bit of writing a Markov model in Excel from R. So I think that it is laborious to do this, but the functions in Excel themselves, there's often a R equivalent. And on the Reaver project, we've already mapped a lot of that out as well.
Thanks.
Question online, so I can ask that. So from what I understand, the R script needs to be run again for every case. Usually we make changes to the Excel file immediately for scenario analysis.
Yeah, so once it has been exported, you can change the Excel sheet and run scenario analyses there. You don't need to run the R model again. So once the Excel is written in a way that it's human readable, so it is already something that you could play with and modify yourself. And that was one of the main objectives of this. So you can do your scenario analysis in Excel and forget about the R.
Really interesting, thanks. I don't know if I missed this in your earlier presentation, but is it possible to start working from an already populated Excel sheet, so something like a template that others might want?
So that's if when you so Excel template, yeah, a populated Excel model is a different issue because you're modifying an existing model. But if you have a template, say a company uses a specific template, you could write the R code to write into that template and follow that formatting using the formatting options of OpenXLSX. So that's certainly possible. There was.
Is there much of a limitation on how you write your model in R? Like, you know, I would expect there to be some limitations on, you know, if I write an R model in a completely wild way, that you would find it very difficult to translate from there. Is that the case?
Yeah, so
Is there kind of a really standardized way that you should write your R model for this to work?
that is a limitation. So the way this is written, you need to follow the format of this object-oriented system we've written for writing R Markov models. So long as you write it within that and make adaptations following that style, it'll still be able to export to Excel. But if you try to write a discrete event simulation model using our template, it's not going to work because that's breaking the format. But I think it is possible to write a template that would work for any type of model, but it does add an overhead to the model development because you need to keep these data relationships in place. On the other hand, the data relationships are a good thing to be keeping track of in general, and following a standardized format for your models is also a good thing in general. So this might be a good rather than a bad.
Any other questions? Got time for one more? Otherwise, I'd like to thank Howard for a great presentation.